a little bit windy out here today, a little bit noisy, but I'll see how this is going to work out. This is the Verner Motors 3V. They call it their Scarlet 3V. It is a 42 horsepower at 2,500 RPM. Maximum torque is delivered at about 2,100 RPM. It comes from the Czech Republic. Check out vernermotor.com for their website. And they've been building aircraft engines since back in the early 80s. This particular engine is about the same horsepower as the Scott Castler 45 horsepower or 42 horsepower half VW. But they delivered that 45 horsepower 42 at 3,600 RPM. So you end up with a much smaller prop. This is a 67 by 28 prop one here. The half VW, I run a 54-inch diameter prop, and so there's a lot more wood out here. I end up with a little over 205 pounds of thrust, static thrust, and what this is a 3-cylinder radial. Now there's not too many 3-cylinder radials that are flying airplanes around, but Verner has done it. This particular engine has electric start. Now with the electric start removed, firewall forward, I'm 4 pounds lighter than the half VW. And I normally have the electric start removed, but I was flying over a lot of water, and I wanted every safety measure I could get, every little help in case there was a problem. So I put it back on. I'll be taking it off before I get to Oshkosh. The cylinders are aluminum cylinders with a steel sleeve. The heads are a Honda industrial engine. There's tons of those made all over the world and in use. Well-proven head, well-proven design. The engine is a dry sump system, so there's no oil in the crankcase except as it drains back to get into the tank. The tank is underneath, and the big line is the return line from the crankcase. The smaller lines are the return from the cylinder heads, and the line on the right, this line right here, that's the suction up into the oil pump. Now they've got an oil filter here, so it's got a neat little oil filter. The pistons, I understand, are Porsche aftermarket pistons. These intake tubes are carbon fiber. There are 3 CDI ignition systems, one for each cylinder. Each one of them has a pickup up here, so each one is totally independent. This is a tachometer pickup. Now, one of the things I did is I took the WB, the Walbro WB 37 carburetor off. It comes with a fuel pump. It worked great, but I couldn't get the mixtures and the EGTs where I wanted them at idle, mid-range, or at full power. So I went to the Mikuni. This is a Mikuni VM26-606. I put larger jets in it, both in the idle side and in the main jet size, and seems to be working great. At 2,050 RPM cruising, I'm getting about the same speeds I was with the half VW cruising, and I'm using 2 gallons an hour. The total overall of this engine compared to the half VW, this one will outrun it and outclimb it, and I believe it has to do simply with the fact that you've got the torque, you've got the ability to run a larger diameter prop with more pitch at a lower RPM, and it's more efficient. But compared to the half VW, there's absolutely nothing wrong with the half VW, the 42, 45 horsepower, or even the 37 horsepower. And in terms of cost, the 37, you can buy about 2 of the 37 horsepower half VWs for what one of these would cost. Now, the area right in here, there's a blower. So when the fuel goes in, there's a blower wheel, and what it does is evens out the fuel flow and the air going into each of the cylinders, so each of them are the same. Now, one of the areas that I have experimented with, and I believe I'm on the better side, is how to get this engine to live on a motor mount. Now, I'm using a standard Volkswagen half VW mounts. I go into a framework and then I come out, and what I've got at this point in time is these bushings mounted in such a manner that when this engine shakes, and this engine shakes along the center line, that shake goes into those rubber bushings. If you've ever looked at a Rotex, they have the same concept. And these bushings are 90 degrees to the center line of that motor, so that when it shakes, it puts that force into that rubber. When it pulls, then it puts a side load on that bushing, just like they're designed to do. And Lord and Berry Mount both make that bushing with different durometers, so that you end up with axial and lateral loads. So I can change those to get a little bit stiffer or a little bit softer. Now these are already not the softest, but when I get home, I'm going to go to a little bit stiffer one to see what that does. But this has got almost 40 hours on it, and it's working great. This engine, what it does, it shakes around the center line of the engine. At idle, under basically 600 RPM or below, and if you get it down into the low fives, you can sit there and watch it. Whenever the piston fires, when you have ignition, it tries to move the piston and the crank one direction. So the engine starts moving one direction, but then you got the prop moving the opposite direction. So you end up with I'll call it a shake, a wobble, a movement. And then when the next one fires, it happens again. And at low RPM, below 600 RPM, you can sit there and watch each of those events happen. One event, the next, and the next. When you get above roughly 650 RPM up to a little over 1200 RPM, those events are not, they don't cancel each other out, and you get what I call a shake. And that's where the engine, if you're watching the videos or watching the engine, it's moving around and shakes pretty good. Once you get above about 1300 RPM, it smooths out, and from about 1400 RPM up, it is smooth as any engine I've ever flown. I typically fly at 1700 RPM. I'm losing altitude. At about 1800, I'm maintaining altitude. Going cross country, I like to cruise about 2050. I can run it continuous as high as 2200. I have for several minutes at 2300. Now, the manufacturer rates it from 1700 to 2200 for continuous operation. And it's a great engine. It works. Now, I have a gravity feed on my Makuni, and anyway, I have an oil tank down there. It is total 5 quarts, 3 quarts of oil, 2 quarts of air to allow expansion. And other than that, that's about it. Oh, it has an electrical system. Down in here, you got your coils, and you make power. And then over here, you got your voltage regulator. The starter motor is standard automotive. I got a Life Epo core Scorpion battery, weighs 1.1 pounds. It'll start the engine, takes care of everything I need, and at 1.1 pound, can't beat it. And that's included in the firewall forward weight, as well as the oil tank, the hoses, the bolts, everything. Anyway, the propeller on this is a performance propeller by Frank Johnson down in Doney, Texas, and he builds a spectacular propeller. Anyway, I'll kind of zoom into this Verner motor right here. Verner does an excellent job of building these engines. and I can highly recommend them. They've been great to work with, the factory, getting me whatever I needed in a hurry, and it's been a great experience. Okay, that's all for now.